Hi, in this video, I will start the linked list implementation from scratch. So, first of all, let's create a distinct class for the nodes in the linked list. It's going to have the class node with read object. This is how we create a class in Python. And we are going to have a constructor. So we define the init method. Basically, this is how we represent the constructor in Python with the self and the data. Basically, whenever we instantiate a node, we are going to specify the data we would like to store in this node. So we just have to create this data accordingly. And there's going to be another feature of the given node. We are going to store a reference to the next node. It's going to be initialized to none at the beginning. Okay, so that's all about the node. Every node is going to store the data itself and going to store reference to the next node. This is how we construct linked list. Then we have the linked list class with the object. Okay, we have the init constructor with the self, and basically we are going to create the head of the linked list. Basically, it's going to be the first node in the linked list. Okay, and we have the self.size, which is going to be initialized to 0. So it's very important that it is like a tree-like structure. Okay, so that's all about the head and the size, and we are going to have a method. For example, insert start is going to insert some data at the beginning of the list. So first of all, we have to increment the size, so self.size plus 1. We just increment the size and then we have to instantiate, and new node is going to be a node with the data. This is how we instantiate a class in Python. And if not self.head, which means that basically this head is a node. It means that it's going to be the first item in the linked list. So we just have to set the self.head to be equal to this new node. So we just initialize it to be the root node or the head of the linked list. And else, we know that we have already have the head or the root node, whatever we call it. Basically, this is the first node of the linked list. So else, we set the new node that next node to be equal to the self.head, and self.head is equal to the new node. If not self.head, it means that if this is the first node, we just set the head to be equal to the new node. Anyways, we just have to update the pointers. This new node is going to point to the head, and the head is equal to the new node. So this is how we insert item at the beginning of the list. It's going to be order 1 time complexity, which very fast. Basically, this is why we like linked list. Okay, then how are we going to define, for example, the size? I'm just going to have a method, for example, size. It's going to return with the self that size. Okay, and what's very important that we could implement the size, for example, size to method, and it's going to iterate through basically the whole linked list and going to calculate that how many items are stored in the linked list. So we have the actual node is equal to the self dot head. We have our size to be initialized to 0. And while the actual node is not the none or null, then we just have to increment the size. So the size plus equal to 1. And we have to increment basically the actual node is equal to the actual node dot next node. We just returned with the size, and what's the difference between the two size method? That this is going to have the order 1 time complexity, and it's going to have the order n linear time complexity. And basically this is how we initialize it to be 0, and on every insertion we just increment a size because we are able to get in order 1 constant time complexity. This is going to work fine, but on every time we want to calculate the size, we have to consider every single item in the linked list, not that efficient. Thanks for watching.